Someone on your team just proposed replacing your message queue, your search service, and your job scheduler with Postgres. And the terrifying part is they have a point. In today's video, we'll find out how a 30-year-old database became the default answer to problems it was never designed to solve, whether that's genius or a disaster waiting to happen, and what it means for the services you're currently running in production. It is May 17th, 2026, and you're watching Runtime. Postgres has always had extensions. The architecture was designed for them in the early 90s, the idea being that the core stays lean and you bolt on what you need. For decades, this mostly meant PostGIS if you were doing geospatial work, maybe PG stat statements if you cared about query performance. Useful stuff. Niche stuff. Then something shifted. pgvector landed and suddenly Postgres was a vector database. pgcron made it a job scheduler. pgpartman handles table partitioning at scale. Citus turns it into a distributed database. There's an extension that adds columnar storage. There's one that embeds a full JavaScript runtime inside the query executor. At some point, this stops being a database with plugins and starts being an operating system with SQL. Here's the actual reason this is happening, and it's not because Postgres is magic. It's because distributed systems are expensive. Not expensive like, we should optimize this. Expensive like, you need separate deployment pipelines, separate monitoring, separate on-call rotations, separate failure modes, and a distributed tracing setup that will consume 6 months of an engineer's life and still not tell you where the bug actually is. I spent 3 weeks tracking down a race condition that turned out to be a clock skew between two services that shared exactly 0 code. pgvector is the clearest example of the pattern. 2 years ago, the standard advice for semantic search was spin up a dedicated vector database. Pinecone, Weaviate, Qdrant, take your pick. New service, new SDK, new infrastructure, new bill. Then pgvector hit version 0.5, added HNSW indexing, and the performance gap closed enough that, for most workloads, the dedicated service stopped making sense. Supabase, Neon, and pretty much every managed Postgres provider now ships it by default. The standalone vector database market did not enjoy this development. And this is where the microservices comparison stops being clever and starts being a warning. Remember 2015? Every architecture diagram looked like a Jackson Pollock painting of boxes and arrows. Teams decomposed monoliths into services because the promises were real, independent deployability, isolated failure domains, polyglot freedom. The promises were real. The operational reality arrived later, in the form of a distributed monolith that was harder to debug than the thing it replaced. Loading your Postgres instance with 15 extensions is not free. Each one is compiled C code running inside your database process. One bad extension, a memory leak, a seg fault, a locking bug, and your entire database goes down. Not your search service, not your job queue. Everything, your writes, your reads, your foreign keys, all of it. 1 minute you're running a job scheduler and a vector index and a time series rollup. The next minute you're explaining to your CEO why the checkout page is returning 500 errors, because a background aggregation task corrupted shared memory. The managed database providers have made this worse by making it easier. Neon, Supabase, RDS, and Friends have turned extension installation into a checkbox, which is great until you realize that not all of them support all extensions, that version pinning is murky, and that upgrading your Postgres major version with a dozen extensions installed is an adventure you do not want to have on a Tuesday afternoon. The operational complexity didn't disappear. It moved. It's now hidden behind a UI. But here's what the skeptical take leaves out. The microservices era didn't fail because distributed systems are bad. It failed because teams applied distributed systems to problems that didn't need them. A 10-person startup running 12 services with a combined traffic load that a Raspberry Pi could handle. The Postgres extension story is the inverse of that mistake. It's consolidation as the default instead of decomposition as the default. And for a vast number of real applications, the ones that don't have Netflix's traffic or Uber's geographic complexity, keeping your operational surface area small is not a compromise. It's the correct architecture. The engineers reaching for pgvector instead of pinecone aren't being lazy. They're being honest about what their system actually needs. The lesson from microservices wasn't services are bad. It was complexity has a cost, and you should pay it deliberately, not accidentally. Stuffing Postgres with extensions doesn't exempt you from that rule, it just moves where the debt lands. If you're doing it because your workload genuinely fits inside one process and you understand the failure modes, that's good engineering. If you're doing it because a managed dashboard made it a single click, you've just traded one kind of accidental complexity for another. This has been Runtime. Thanks for watching, and I will see you in the next one.